Today we're going to go over box plots. Box plots are a data representation, and we're going to just take the time to look at how to make sense of them and how to read data from them as well. Okay, I have a diagram here of a box plot. The 5 things to look at in a box plot are the minimum, the lower quartile, the median, the upper quartile, and the maximum. And something to note about why we distribute data according to this figure here is, as you read there, it talks about how 25% of the data exists in between the different values. So yeah, what this representation does is it breaks up our data into 4 quartiles. So this is there's 25% in here, 25% in here. So a quarter of your data can be found in each of those little zones. Let's get into number 1. Give the median of the box plot above. So the median is that vertical line that goes through our box part of our data representation. That is your median. The median of this box plot is 45. Number 2 asks us to give the minimum or the lower extreme of the box plot. So that's this value way over here. That's called the minimum. And that would be 41. So that would be the lowest value in the data. Number 3 asks us to find the maximum, which is the greatest value in the data. So that would be here. And that would be 50. Number 4 asks us to find the first quartile or the lower quartile or Q1 of the box plot. So that would be this edge of the box here. So that's known as the first quartile. So that would be 43. And in the same box plot, we want to find the upper quartile, Q3. That'd be right here at the upper edge of the box, 48. So number 6 has us look at home sale prices according to 3 box plots. It says, which city has the most expensive homes? So you can see that the 3 box plots do have overlap, but the box plot that reaches into the highest prices would be city number 2. Right, as you can tell, it has data that reaches all the way up to home values up to there. Whereas the other 2 cities, the maximums, right, their upper extremes, don't go quite as high. So city 2 does have the most expensive homes for sure. So that'd be city 2. Number 7 asks, which city has the least expensive homes? Meaning which box plot shows data or has data that goes to the lowest prices possible. So if you look at city 3, this one kind of reaches down all the way into the 30s, 40s, around there, where the city 2 does kind of reach down almost to city 3, but not quite. So city 3 for sure has the lowest data value out of the 3 box plots. So city 3 has the least expensive homes. Number 8 says, which city has the smallest range, also called spread of the home values? And visually, that just means which box plot is the smallest, according to the same scale. So city 2 would have the widest range because it goes so far up on the Y scale and so low on the Y scale. But this city right here, city 1, I hope it's obvious that city 1 is the smallest vertical spread, and therefore that has the smallest range. City 1. Number 9 asks, what is the median home value of city 1? So I'll zoom in here. And city 1 looks like the median, which is that line that goes through the middle of the box, would land somewhere around 70, very close to 70, maybe a little bit above. And according to my estimates here, it makes the most sense to choose C, $70,000. Number 10 asks to select all the cities that could have a home priced at $50,000. So in order for a home to have a price of $50,000 in the data, the box plot has to reach down to that data value. So if I zoom in at 50, hoping it's obvious here, any box plot that has data around that level should have a data value around there. So it's possible that city 2 and city 3 should have a data value of 50, so $50,000. So cities 2 and 3 could have a home price at $50,000. City 1 does not have a home that reaches down to that price. Number 11, the box plot is made from the data 4.5, 6, 6, 6.5, 7, 7.5, blank, 9, and 10. Give the value of the missing number from the data. Let's first talk about the median. The median of this box plot has to be 7. And as you can tell, if you look at the values here on the left and on the right, there's 4 values on the left and 4 values on the right, and that would make 7 our median. So 7 lands right in the middle of these 9 values, and that makes sense that it is the median. Now, if you try to find the median of the lower 50% and the median of the upper 50%, those are our quartiles. So if you look at the left here, there's 4 values, so the median would be the mean of these 2 values, so that makes sense that that is our Q1. So there's our Q1, and that makes sense, that's Q1. Now, over here at Q3, that should be here, quartile 3. So we see it on the box plot that it should be 8.5, but they give us a blank there. So we have to figure out the mean of what 2 values, right? Because there is no middle value in those 4 data points. So basically they're asking what plus 9 divided by 2 equals 8.5, and the answer is 8. So I'll leave it for you to check, but 8 plus 9 is 17, divided by 2 is 8.5. What percent of values in the data are greater than or equal to 3? So if you look at our box plot, 3 is right here. So basically what they're saying is what percent of values would cover the entire box plot? Well, that would be the whole data set, so that would be 100%. Number 13 says what percent of values in the data are less than 13? Well, 13 happens to line up with our quartile 3. So each quartile or each quarter of our data holds 25%. So if we're less than 13, that means 25% is here, 25% is here, and 25% is in this little strand there. So 75% of our data is less than the 3rd quartile, so that would be 75%. 14 asks us to find the percent of values that are less than or equal to 16. So 16 is kind of awkward because it's not on a quartile or a maximum or a minimum or a median. So we do know that there's 25% here, here, and here. So it's greater than 75, but less than 100. So from the choices here, I think we're unable to determine the answer there. So just know if we're not at a specific quartile or median value, you can't really make a call. I mean, you can give a range of values. So I could say it's more than 75%, but less than 100. But other than that, I think from those choices, we'd have to say unable to determine. Okay, what percent of values in the data are greater than 10? 10 is our median. So our median splits our data half and half. So if it's greater than 10, that'd be everything on the right side. That would be 50% of our data, right? Because it includes the 2 25% quarters, the upper quartile and the upper extreme. So that'd be 50%. All right, so I hope that helped you with box plots.